Hello folks, welcome to Coding Epochs. So today we'll be discussing about PyTorch tensors. So I'm on the official documentation for PyTorch in the section for tensors. So as you can see, the definition for a tensor is a multidimensional matrix consisting of elements of single data type. So you can find this very similar to an array, a NumPy array or a list in Python. It is very similar to that. And if you already know NumPy, most of the methods in the tensor is similar to methods in NumPy arrays. The only difference and the main difference that differentiates a tensor from a NumPy array is that tensor can be loaded to a GPU and you can perform all the computation inside a GPU, which will tremendously boost up the speed of our neural network training because most of the activities are matrix multiplications, and matrix multiplication speed can be increased really fast when we put it in a GPU. So without further ado, let's get started. I'll be using Google Colab for this particular tutorial. Google Colab already have PyTorch installed, so you don't have to manually go and install PyTorch to your system. If you have already PyTorch installed in your system, you can follow along, or else you can go to Collab and start follow along with me here also. So before starting, just make sure that you go to the notebook settings and have selected GPU as a graphic hardware accelerator. It will help us to use GPU, and we can also see how to get a tensor into GPU further in this session. Okay, so first we'll do our major imports. So Torch is a major library we need. We'll be also using NumPy because NumPy and Torch are tensors are super related, so we can study correlating both these data structures. Okay, so first we'll just create a simple Python list. Uh, okay, data, a 2D list, and this list contain two items, and we'll create a tensor from this particular list. So we call this x data. That will be equal to torch dot tensor. This is a method to create a tensor. We'll pass in the Python list as an argument. Press enter. We just print the tensor we created as well. So you can see we got a tensor object from this Python list. So that's how we create a tensor from a Python list and populate it with the data from the list. We can also create a tensor using a NumPy array. So first, let's create a NumPy array. 2np.array of data. Then x and p will be the tensor generated from this NumPy array. So the method we're going to use is torch.from NumPy, and we'll pass this NumPy array as an argument. We just print this tensor once it's created. Okay, again we got another tensor from a NumPy array. Okay, so now let's see how we can generate tensors, random tensors of a specific dimension. So see, like if I want to create a random data set or a random tensor of particular shape, what I can do is I'll just create a random tensor. We can use this torch.rand. It's a synonym for random. We can give any particular shape, so I can give a shape of 2, 3. It will just print out the tensor to see what it's look like. And a random tensor that PyTorch has created for us with the specified dimension which we give. So we don't need to explicitly give the value. We can also create random tensors. We can also create tensors with only ones and zeros. There are methods called ones. This will create a tensor of the required dimension, but all elements will be ones. This again applies to zeros as well. Uh, this can be handy when we're, making dummy labels with 0, 1, maybe binary classification, all the stuff. It can be very useful for that. Okay, now we'll see what are the major attributes of a tensor. So the main attributes of a tensor are its shape. So we use this rand tensor, which we created previous cell dot shape. It will just return its shape. Okay. Another property is tensor dot dtype. Dtype is data type. So the data type of a tensor is float 32. So when we are using this rand np zeros or ones, we'll be having a data type of float 32. That's the default data type that's returned by PyTorch. Okay. So now let's get to the most awaited part, that is how to move our tensor to a GPU. Before that, we have to check whether our system has a GPU. So PyTorch have a method for that as well. We use torch.cuda is available method. It's a function. Return true because we have enabled GPU in Google Colab. If you're using a local system, you must have a valid NVIDIA GPU to get this as true. Okay, so once we have this, we can move our tensor to GPU. So basically, once we are creating the tensor to be in the CPU, we need to explicitly move our tensors to the GPU whenever it's needed. So to move our the tensor to the GPU, it's very simple. We can use this xdata tensor. So xdata equal to xdata to you'll see the name of the GPU, it's CUDA, and we have xdata in GPU. We can verify that by using the device parameter of a tensor. Yeah, we can see that its type is CUDA, so our tensor is successfully being transferred to the GPU. The last part, we'll just see how arithmetic operations are done in a tensor. So for rand tensor, we'll just multiply. We'll just do matrix multiplication. So rand tensor dot matmul, if you have used NumPy, is a similar method. So we just multiply rand tensor with rand tensor itself. It was an underscore here and store to y, and we'll print y. Okay, it cannot be multiplied because shapes don't match. So what we can do is we'll transpose the same matrix so it matches and we get the output here. So that's the matrix multiplication here. So our random tensor was a zero tensor, so multiplying it will give us a 0. So we just change it to a random value. Uh, you can see the random value here, and we'll again run the cell, and we get the multiplied output here. Okay, so that's all, folks. That's all about the basics of PyTorch tensors. You can read more about tensors in the official documentation and all the available methods. So learning how to use tensors is a very important skill in PyTorch, and it's a very basic thing that we need to understand to get started with PyTorch. So that's all for today. Hope you enjoyed the video. Please don't forget to subscribe to the channel. We'll see you in the next video. Thank you all.